Okay, so you guys are working on 12.2 today. So we are on unit 12.2. Yep. Unit 12.2. Okay, and we're going to be working on arithmetic sequence to start with. Arithmetic, you don't say arithmetic, it's arithmetic sequence.
Why can't we just say arithmetic?
Arithmetic sequences, okay? First thing you need to know is that a sequence is just a list of numbers, okay? Sequence means it is a list, okay? So we're going to first start with an arithmetic sequence. You know if something is arithmetic if it has something called a common difference, okay? So the definition of being an arithmetic sequence means it has a common difference. So the definition would indicate that it has a common difference. Common difference, we're just going to write as D, common difference between each term. So essentially, if I just gave you, if we're going to start with, is the following an arithmetic sequence? Is the following an arithmetic sequence? And on your homework, it's going to ask you to explain. Okay, so is the following, an arithmetic sequence? And I want you to explain why or why not. So for example, number 1, if I take 7, 11, 15, 19, and we're going to say ... Okay, so a sequence is just a list of numbers. Okay, an arithmetic sequence is when a list of numbers has a common difference. Okay, so first thing we need to do is we're going to label these. Okay, first one I'm going to label as term number 1. So would you agree that that's term 1? Then 11 would be term 2. We call these term numbers. Term 3, term 4. Okay, and of course we could keep going. Okay, you could have as many terms in a sequence as you want. It's just a list. But that's a little long to write, term for every single one, so we're going to label these a little bit differently. We're going to write this as A sub 1, okay, we label that as A1, but really we just call it term number 1. Then 11 is A2, notice those are subscript, okay, why they're not T's, I'm not sure. I think it's probably because T's look like plus signs and we don't want to write those. So A2, A3, A4, and so on. The way that you tell if something has a common difference is that D is equal to, you can basically take any term number and subtract the one in front of it. So I could do A4 minus A3, or I could do A3 minus A2, or we could do A2 minus A1. Essentially, you could figure out the common difference by taking any term and subtracting the one in front of it. So if we did A4 minus A3, that would be 19 minus 15, and what would that give you for a difference? 4. Now, you can't just look at one. We need to check them. Okay, so A3 minus A2 would be 15 minus 11. That is also 4. A2 minus A1 is 11 minus 7, which is also 4. So, is this an arithmetic sequence? Is there a consistent difference between each term? Yes. So, is the following arithmetic sequence? Explain. The answer here would be yes, because it has a common difference. Because there is a common difference. So literally for your homework, you would write out the sequence, okay, write the list, and yes, you have to write it down or else it's not showing enough work. Yes, common difference. Those are the 3 key words I have to see. Okay, so yes, common difference. If it is not a common difference, you'd write no, No common difference. That's it. That's the explanation part. Simple enough, right? I hope. Please tell me yes. Okay. Number 2. Same thing. I still want to know, is the following an arithmetic sequence? Explain why or why not. If I gave you the terms 59, 56, 53, ... Now, obviously, if we're going to figure out if something has a common difference, you can't just have 2 terms. Okay, you have to have more than 2 because you have to be able to complain. So, does this have a common difference? So let's label these. This is your A1, A2, A3, and it would keep going. So you need to take any term and subtract the one in front of it. So to find the difference, you have to take any term and subtract the one in front of it. So, and we need to check it. Now, do I really expect that you're going to show work on this? Probably not, but I'm going to show it to you just in case. So if you took A3 minus A2, that would be 53 minus 56. What would your difference be here? -3. Check it. You also have to check A2 minus A1. 56 minus 59 gives you -3. So the common difference could be positive. Like on this one, you're really adding 4 to get to the next term. Here, what are you adding to get to the next term? D is -3. So I want you to think of, what are you adding to get to the next term? You are adding a negative number here. Okay, so we're always figuring out, what are you adding to get to the next term? So is this an arithmetic sequence? Yes, common difference. Okay, yes, there is a common difference. Questions on how I did that? We're good? Hopefully. Okay, so that's your actual answer. Let's try one more that's like that for number 3. If I ask you, is the following an arithmetic sequence? 1, 1/2, 1/3, 1/4, and so on. Can you add or technically subtract the exact same thing to get from one of these numbers to the next one? First off, if you have fractions, and I know you guys don't like to deal with fractions, if you have fractions, you have to have common denominators. So what would the common denominator be here between 2, 3, and 4? 12. Okay? How to write 1 whole as twelfths? How many twelfths are in 1 whole? 12 twelfths. How do I write 1/2 in terms of twelfths? 6 over 12. How do I write 1/3 in terms of twelfths? 4 over 12. And how do I write 1/4 in terms of twelfths? 3 over 12. You can look at this and figure out, what would you add 12 plus what equals -6, or equals 6? I just gave you the answer. -6 over 12. So I would show your common difference like this, like show it in between each one. How do you get from 6 to 4? What do you add to get from 6 to 4? -2 over 12. Automatically, can you tell there's not going to be a common difference? Okay, so automatically, is this an arithmetic sequence? No. No common difference. Did I really need to get to this one? No. Okay, you can already tell that there's not a common difference. So when you have fractions, you do need to get a common denominator. Now, next thing we're going to do is writing the rule. Okay, we're going to ask you to find the rule, or find how to write an arithmetic sequence. Okay, so what you first need to know is that the general formula for an arithmetic sequence. The general formula for an arithmetic sequence is A sub n is equal to A1 plus D times n minus 1. And I'm going to explain to you what all of those things mean in just a second. You guys do still need to be taking notes, because you will still definitely be taking notes quizzes. And dependent upon how you act in class, I will then decide based on what the sub says, whoever your sub, well, actually what Ms. Duffy says, because she's going to be here for all of Unit 12, if you get to use formulas or not on this test. So I would suggest doing homework and paying attention and being respectful. It would be beneficial to your lives if you would like to use formulas. A sub n equals A1 plus D times n minus 1. A sub n, basically what this means is to find term number n. Term number n. So it could be any number. Could be to find term number 4, to find term number 20, okay? What you do is you're going to plug in, A1 is always the first term, plus, what does D stand for?
Difference.
Common difference. Multiplied by, n stands for the term number minus 1. Okay, so to find any term number, to find term number n, you will plug into, and you're going to use the first term plus the common difference times term number minus 1. So for example number 4, we're going to make this a little bit easier now that we have numbers to work with. If it is given, so I give you that A sub n is equal to 5 plus 3 times n minus 1. And I ask you to find the first 4 terms. This is exactly what you did on Friday. Okay? You were given terms and we asked you to find the next ones, basically. Okay? So here, if I give you this formula, I want you to find the first 4 terms. So to find term number 1, A1 would equal, and you're just going to plug in here. This number here is what you plug in for n. So you would do 5 plus 3 times 1 minus 1 and work it out. You can work it out on your own. Then do A2, and we're going to do this for all the way through A4, and you're going to make an arithmetic sequence. So you're going to tell me what is the list if I plugged into these. So you do 5 plus 3 times 2 minus 1, 5 plus 3 times 3 minus 1, and 5 plus 3 times 4 minus 1. You are capable of doing basic arithmetic. Use your order of operations. So really this is 5 plus 3 times 0. So really 5 plus 3 times 0 gives you what? 5 plus, what's 3 times 0? 0. 5 plus 0 is 5. This is 5 plus 3 times 1. 3 times 1 is 3. 5 plus 3 is 8. This is 5 plus 3 times 3 minus 1 is 2. 3 times 2 is 6. 5 plus 6 is 11. What do you think my next one's going to be? What are we obviously increasing by? 3's. So this would be 14. Okay? So if I asked you to write the first 4 terms in this arithmetic sequence, you would write 5, 8,
Is Jake up here?
11, and 14.
Yeah, he is.
5, 8, 11, and 14.
I saw that coming.
5, 8, 11, and 14. That's the answer. 5, 8, 11, and 14 are your answers. Okay, so if you're finding the first 4 terms, it's just plugging in. I could ask you to find 6 terms. I could ask for 3. Doesn't matter. You're just plugging into a formula. Questions on how you did that? Should have done that. Next thing you're going to do, oh, yes.
Do we have, like, can't we just, like, it says find the 12th, 13th, and 14th terms, can't we just find the 12th and then add the common difference?
You could.
But do we have to work it out? Like,
Well,
do you
okay,
require
I understand what you're saying. You need to show as much work as you think I would like to see. There you go. Let's say that. Next one for number 5. Okay. Now, if you were given, if I give you this arithmetic sequence, and this time we're going to go backwards. If I gave you this arithmetic sequence, now I would like you to find the rule. So find the formula. Most of your problems are not going to be just plug in. Okay, that's what we give to like 7th or 8th graders. You guys are going to have to go backwards. Now, this is the exact same sequence that I just came up with. So you should know the rule, okay, because I gave it to you at the beginning. But I'm going to show you how you would go backwards and do that. So first thing you're going to do is write the rule. So the rule is AN equals A1 plus D times N minus 1. And we are going to go backwards, okay? First thing you're going to do is you're going to replace everything except for N. So we're just going to cross this out for a minute. Okay, that's what our answer is going to be. This is what we're finding. And we're going to plug in as much as you know. Okay, do we know what A1 is? A1 stands for what? The first term. So what's the first term in this sequence? 5. Plus, what's your D? What's the common difference? What do you add to get from one term to the next? 3. Times N. You don't know that. You are going to leave it as N. Minus 1. Then we just simplify. So how would you simplify this? You would do 5 plus distribute 3n minus 3 and then combine like terms. 5 minus 3 gives you what? 2. We always write the n part first, so 3n plus 2, write in an. That is the formula that I am looking for. That is the answer that we are looking for here. Now, what's actually going to happen on your homework is we're going to give you this, we're going to ask you to write the rule, and then find a particular term. So I might now say find a sub 20, okay, which would be the 20th term. I'm not asking you for that one on this question, but I will be. Questions on how we did that? Okay, let's do one more that's like that. Yes, these are kind of long notes. Sorry, you'll be okay. Huh?
Is this like the hardest it gets?
No. So, next I'm going to write the formula for 9, 15, 21, 27, and so on. So I'd like you to write the rule for this arithmetic sequence. Write the formula or the rule for that. So again, we're going to start with whatever your rule is. So AN equals A1 plus D times N minus 1. This part is what you're leaving alone. You're not going to plug in anything for right here. That's going to be in your answer, but it doesn't need to be part of your problem right now. A1, what should I plug in? 9. Plus, what's your D? What's your common difference? 6 times N minus 1. Distribute. So 9 plus 6 times N is 6N. 6 times negative 1 is negative 6. And clean it up. AN equals... You always want to write the n part first and then the numbers by themselves at the end. So 6n, 9 minus 6 gives you plus 3. That is your rule. Now, this is not quite enough though. Next, we're going to ask you to now find A20. So it's very important that you get the rule right, because if you don't get the rule right, you're not going to get the actual question right. Now, technically, you could keep going on here and you could find the 20th term. So I could just keep adding 6 and I could keep going. But it's going to take a lot of work. That's kind of unnecessary. Okay? Plus, if I asked you for anything past like the 20th term, that's just really annoying. So you don't want to do that. So now to find A20, we're going to plug things in. So A20 would equal, and I'm going to plug into my formula. 6 times, what do I plug in for N? 20. 6 times 20 plus 3. So 6 times 20 plus 3 is 23. You can multiply that. What is 6 times 23? You don't need to use calculators on this unit either. 138. That is the second part of your answer. Questions on how we did that? Nope. We're halfway done. Okay? That was called arithmetic sequences. Next thing we're going to go over is arithmetic series. Okay? These are big notes. That's why I'm doing them for you. Okay, this is a difficult set. Okay? Next thing we're going to go over is something called arithmetic series. Okay, arithmetic series. An arithmetic series, a series is when you add up all parts of a sequence. So an arithmetic series is when you add up all the parts of a list, essentially. Okay? So here, for example number 1, I would like you to find the sum of 1 plus 2 plus 3 plus all of the numbers up to 100.
Do you know you only get Saturday school for
I don't want to hear it. I would like you to add all the numbers up from 1 to 100. Go. 1 plus 2 plus 3 plus 4, every whole number up to 100. Essentially, at some point somewhere, there was a person, a famous mathematician, his last name was Gauss, G-A-U-S-S, did the following. Okay? He realized that if you added all these numbers up together and kept going, okay, and then kind of flipped it around, he realized that they would all match up. This would be 52. So they would match up every single number. And he would add them all up together. So he realized there was a pattern here. Okay? If you added up all these numbers, 1 plus 100 is 101. 2 plus 99 is 101. He realized there would be a lot of sets of 101s. Again, 101. How many times would he add up sets of 101? 50 times. Okay? He realized there are 50 sums of 101. So essentially he realized he could just do 50 times 101. What is 50 times 101? Seriously? What's 50 times 100? 5,000 plus one more set of 50, so 50-50. He realized that this would give you 50-50, okay? And he realized that basically he could write a formula for this, okay? The formula that he discovered, or created basically, is the number of terms. You could take the number of terms divided by 2 and multiply it by the first term plus the last term. He realized that you could take the number of terms divided by 2 and then multiply it by the first term plus the last term. So the actual way that we write this formula is S sub n, S stands for sum of all the terms, is equal to n over 2, which is your number of terms, times a1 is your first term, plus an is your last term. This is another formula that you will need to memorize. It is not an option. You need to memorize it.
Is that 9 or 8?
An. Sorry, those are A's. A1 plus an. A1 plus an. Say again. This is long. Go live. Sum of all the terms. Sum of the terms is equal to n over 2 times a1 plus an. So, for example number 2, because yes, I kind of started another separate lecture. Okay, find the sum. Find the sum of 5 plus 9 plus 13 plus 17, 21, 25, 29, and 33. And no, you don't get to use calculators. Kind of. Now, first thing you need to do is 33. I don't know where you got 38. 33 is your last term. So we definitely know if I wanted to label these, this is your A1, right? This would be A2. If you count all the way up here, what term number is this? This is A what? So A1, 2, 3, 4, 5, 6, 7, 8. You first need to figure out how many terms are there. Okay, because we know what the first one is, we know what the last one is. But we need to know how many numbers there are actually. So to plug this into the formula, you're going to get S sub n is equal to, what's the n over 2? Times A1 plus AN. If I'm going to plug in as much as I know, how many total number of terms are there for this equation? 8. So 8 over 2 multiplied by, what's the first term? 5. Plus, what's the last term? 33. And you work it out. So here, 8 over 2 gives you 4 times, what's 5 plus 38? 5 plus 33, sorry, 38. I can talk. If you multiply those together, 4 times 38 is 152. That's probably a lot easier than actually lining these up and adding them all together. That is your answer. Answer here is 152. Yeah, you were actually supposed to do that. Now, that's fairly easy. You just plug it into the example or plug it into the formula. But where it's going to become a bit more difficult is what if I tell you to, again, find the sum of 2 plus 5 plus 8 and keep going in this sequence, because it's a sequence, it's a list still, until you get to 110. So add up all the terms in between 2 and 110 if this is the pattern that you're following. Jalen, what's the problem here? We need to know the total number of terms. Do I know what term number 110 is? Do we know what term number that is? No, but can I figure it out? You're going to have to use the other formula from arithmetic sequence, okay? Use sequence formula. The sequence formula was what? AN equals A1 plus D times n minus 1. And we're going to plug in. The last term here is 110. It's equal to, what's the first term? 2 plus, do we know what the common difference is in this sequence? 3 times n. Do we know what term number this is? No, that's what we're finding. So you're going to solve for n minus 1. And we can work this out. So 110 equals 2 plus 3 times n is 3n. 3 times negative 1 is minus 3. And we're solving for n. So that would give you 110 equals 3n minus 1. What would you do then? Add the 1 to the other side, so 111 equals 3n. Can you get n and solve for what term number that is? 111 divided by 3 gives you what? Yes, it goes in evenly. Try again. 37 equals n. Now, if I know what this is your A1. What term number is this? What number term is this? This is a 37. Now I can take those and I can plug into this formula. Okay, so you have to go backwards. There's a lot of work to be done on these problems. And yes, you have to do it. Okay, so now we can plug into the series formula, S sub n equals n over 2 times a1 plus an, and plug things in. Do I know the n, the total number of terms? What is it? 37 over 2. Already, I know that's an ugly number, but we will live. Okay, yes, there will be some fractions. You will deal with them. Multiplied by what's your a1? What's your first term? 2. Plus what's your an, your last term? 110. If we work this out, do not do 37 divided by 2 yet. Okay, 37 over 2 times 112. What can I do with this 2 and the 112? Cross reduce. How many times does 2 go into 112? 56. So really, we're going to do 37 times 56. You could work that out, but for the interest of time, I'm going to tell you it's 2072. That is the answer for the entire question. 2072. It's all formulas. You just have to plug in the right thing in the right place. Questions? Where did I get 56? 2 into 112 is 56. I cross-canceled. Cross-reduced. Questions? No, we're not done. Yes. Right. Yeah, I would cross-reduce if there's an ugly fraction, yes. Okay, let's try another one. For example number 4. I realize these are long and difficult, but you will be okay. Welcome to the end of the semester. Next, I would like you to find the sum of 19 plus 15 plus 11 plus 7 plus 3, and keep going until you get to negative 165. I'd like you to find the sum of all of those terms in this sequence. So, since we're finding a sum, you're going to start with the sum formula. What is the formula for the sum of an arithmetic series? Sn equals n over 2 times a1 plus an. We're going to plug in as much as you know. Do I know what term number this is? Do I know what term number this is? No, so it's still just n over 2 times, what's your a1? What's your first term? 19 plus, what's your last term? Negative 165. Now, I don't have all the parts. How can I find this term number? Use the other formula, okay? To find n, use sequence formula. To find n, use the sequence formula. And the sequence formula is an equals a1 plus d times n minus 1. So we're going to solve for what term number this negative 165 is. Plug this in here, so negative 165 equals, what's your a1? 19 plus, what's your common difference? Negative 4 times n minus 1, and we are solving for what term number this is. You can work this out. So negative 165 equals 19, distribute your negative 4, minus 4n, negative 4 times negative 1 gives you plus 4. Clean up these two sides. Negative 165 equals 19 plus 4 is going to give you negative 4n plus 23. How do I solve? Subtract 23. Negative 165 and negative 23 gives you negative 188 equals negative 4n. How do I get n by itself? Divide both sides by negative 4. And you should get that this last term is term number 47. Would it ever make sense to get a negative for a term number? No. We're counting the number of terms. I can't get a negative 47th term. That makes no sense. Now, we're going to take this, plug in. So you're going to take this 47 and you're going to plug it in back up here where it was missing. So now we're going to plug in and you're going to get 47 over 2, which is what we were missing, times what was your A1? 19 plus AN was negative 165. We can work this out. So you're going to have 47 over 2. 19 minus 165 gives you negative 146. And you're going to have to solve. Okay, again, this is kind of an ugly fraction. So I would recommend cross-canceling or cross-reducing. This reduces, 2 reduces with 146 to give you negative 73. And then you have to multiply. 47 times negative 73 should give you negative 3431. I take that back. I do believe you can use calculators on this. Sorry, forgot. Do you see how I got negative 3431? Do we see how I got that? We're not done. We're not done. Okay, 2 more. 2 more. Next one, for example number 5. Sorry, guys. I would like you to find the sum. Find the sum of. I'm gonna show you a new symbol. Okay, this is called an arithmetic series. It's going to be kind of like a sideways looking E, okay? That tells you to find the sum of, on the bottom it's going to say n equals 1.
Yeah, we already
On the
had that.
Did you guys do this? When did you do this?
I remember seeing that.
Okay, well now we're going to do it. Thank you. Okay, so here, this is between 7 minus 2n. So I think on Friday you guys saw find the sum of, and it gave you a list, correct? And you actually had to work it out, okay? This is telling you to basically find the sum of, if I plugged in every number between 1 and 16, okay? Every number between 1 and 16, okay? Here, this would become 7 minus 2 times 1 plus 7 minus 2 times 2, and you would keep going, right? All the way up until you got 7 minus, oops, sorry, all the way up until you got 7 minus 2 times 16. Would you agree? Because that's the last number you're going to plug in. Essentially here, we need to figure out what are these numbers. So what is 7 minus 2 times 1? 7 minus 2 gives you 5. 7 minus 2 times 2 is 4. 7 minus 4 is 3. And remember, we're adding all these numbers together. So if you added up every number here, all the way you got to 7 minus 2 times 16 is 32. What would my last number that you're adding up be? Negative 25. I want you to add up every number in between these. What formula do you think you're using? You're using the sequence formula or the series formula? Series formula, okay? The series formula is sum is equal to n over 2 times A1 plus AN. Can you plug in these numbers? Can I figure out how many total terms are there in this sequence? How many total numbers am I adding up? 16, between 1 and 16. So you're adding up every number. If you plug in every number between 1 and 16, you're adding 16 total. Over 2 times what's your first term? 5. And what's your last term? Negative 25. And you can plug that in. 16 over 2 gives you 8 times 5 minus 25 is negative 20. So what's the sum if I add up all these numbers? Negative 160. That is your answer. So I've given you the tools, I've given you all the formulas that you could possibly need to do this. Right? I really have given you all the formulas that you could possibly need to do this. Do we have questions so far? And yes, you're going to do one more. Deal, people. Okay, last one for number 6. Okay, example number 6. I would like you to find the sum of, so that's already telling you find the sum of between n equals 4 and n equals 40 for the formula 2n plus 1. I want you to find every term if I plug in between every number between 4 and 40 into this formula. I want you to add them all up. How would you begin? Any ideas? So I basically need 3 different parts, okay? I know that my formula here is Sn equals n over 2 times A1 plus AN. I need the total number of terms. Do I know how many total terms there are? How many are there? If I add up every number between 4 and 40, is it really 36? What if okay, let's just say, forget that part. How many terms are there if I said add up between all the numbers n equals 4 and 7? How many terms would you be adding up? If I plug in 4, and I plug in 5 and 6 and 7, how many different numbers am I plugging in? 4 of them, okay? So to find the number of terms, you take top number minus bottom number and add 1, okay? Top number minus the bottom number and add 1. So in this case, you would do 40 minus 4 plus 1. Okay, you always have to add 1. So this would give you, there are 37 terms. Okay, make sure you're finding the right number of terms. Unless you'd like to count up, if you're going to add up when you plug in 4, 5, 6, 7, 8, 9, I'll go all the way to 40. Trust me, it's 37. It's a lot easier to just say top number minus the bottom number and add 1. So really, what's your n here? 37. Over 2 by, how do you know what the first term is? What would you plug in first? 4. The first number you plug in is 4. So your A1 is equal to, when you plug in 4. What is your first term? 2 times 4 plus 1 is 9. So your first number is 9. What's the last term? Last term is when you plug in the last number. What's the last number you're plugging in? 40. 2 times 40 plus 1 would give you what? 81. Plug in. 37 over 2 times 9 plus 81. If we work that out, you'd get 37 over 2 times 90. You may use a calculator on this. Trust me, when you multiply it together, it's 1665 for an answer. Make sure that you write down your homework. Yes, it is all due by block day. Yes, it will be collected. Homework is going to be in your book the big book that's probably buried under your bed, get it out. You're going to do page 806. You are doing numbers 3 through 36, multiples of 3. So that means count by 3. So 3, 6, 9, 12. Figure it out. Okay, multiples of 3, as well as 40 through 48 even. I understand those were long notes, but you will live.